The Hadoop ecosystem. So much free stuff. How did the big data open source movement begin? In 2004, Google published a paper about their in-house processing framework they called MapReduce. The next year, Yahoo released an open source implementation based on this framework called Hadoop. In the following years, other frameworks and tools were released to the community as open source projects. These frameworks provided new capabilities missing in Hadoop, such as SQL-like querying or high-level scripting. Today, there are over 100 open source projects for big data, and this number continues to grow. Many rely on Hadoop, but some are independent. With so many frameworks and tools available, how do we learn what they do? We can organize them with a layer diagram to understand their capabilities. Sometimes we also use the term stack instead of a layer diagram. In a layer diagram, a component uses the functionality or capabilities of the component in the layer below it. Usually, components at the same layer do not communicate, and a component never assumes a specific tool or component is above it. In this example, component A is in the bottom layer, which components B and C use. Component D uses B, but not C, and D does not directly use A. Let's look at one set of tools in the Hadoop ecosystem as a layer diagram. This layer diagram is organized vertically based on the interface. Low-level interfaces to storage and scheduling on the bottom, and high-level languages and interactivity at the top. The Hadoop Distributed File System, or HDFS, is the foundation for many big data frameworks since it provides scalable and reliable storage. As the size of your data increases, you can add commodity hardware to HDFS to increase storage capacity. So it enables scaling out of your resources. Hadoop Yarn provides flexible scheduling and resource management over the HDFS storage. Yarn is used at Yahoo to schedule jobs across 40,000 servers. MapReduce is a programming model that simplifies parallel computing. Instead of dealing with the complexities of synchronization and scheduling, you only need to give MapReduce two functions, map and reduce, as you heard before. This programming model is so powerful that Google previously used it for indexing websites. MapReduce only assumes a limited model to express data. Hive and Pig are two additional programming models on top of MapReduce to augment data modeling of MapReduce with relational algebra and data flow modeling, respectively. Hive was created at Facebook to issue SQL-like queries using MapReduce on their data in HDFS. Pig was created at Yahoo to model data flow-based programs using MapReduce. Thanks to Yarn's ability to manage resources not just for MapReduce but other programming models as well, Giraffe was built for processing large-scale graphs efficiently. For example, Facebook uses Giraffe to analyze the social graphs of its users. Similarly, Storm, Spark, and Flink were built for real-time and in-memory processing of big data on top of the Yarn Resource Scheduler and HDFS. In-memory processing is a powerful way of running big data applications even faster, achieving 100 times better performance for some tasks. Sometimes, your data or processing tasks are not easily or efficiently represented using the file and directory model of storage. Examples of this include collections of key values or large sparse tables. NoSQL projects such as Cassandra, MongoDB, and HBase handle these cases. Cassandra was created at Facebook, but Facebook also used HBase for its messaging platform. Finally, running all these tools requires a centralized management system for synchronization, configuration, and to ensure high availability. Zookeeper performs these duties. It was created by Yahoo to wrangle services named after animals. A major benefit of the Hadoop ecosystem is that all these tools are open source projects. You can download and use them for free. Each project has a community of users and developers that answer questions, fix bugs, and implement new features. You can mix and match to get only the tools you need to achieve your goals. Alternatively, there are several pre-built stacks of these tools offered by companies such as Cloudera, Mapper, and Hortonworks. These companies provide the core software stacks for free and offer commercial support for production environments. As a summary, the Hadoop ecosystem consists of a growing number of open source tools, providing opportunities to pick the right tool for the right tasks for better performance and lower costs. We will review some of these tools in further detail and provide an analysis of when to use which in the next set of lectures.